Hello everyone, and welcome back to another day of section 4.5 on dilations. Today we're going to work on constructing dilations. And I have a picture here. I don't want to zoom out, so if you want to read through this without my explanation, go ahead and just pause here. Otherwise, I'm just going to demonstrate exactly what we're doing in these directions down here with the example. So if you recall from our previous lesson, a dilation is just an enlargement or a reduction. So we're making a figure either bigger or smaller. And here we are going to work on dilating a figure with a scale factor of 3. If you remember, the K stands for scale factor. And because we're constructing, we need to use straight edges and compasses. So if you don't have that handy, you'll definitely want to get that. I'm going to label this triangle A, B, C, so we can talk about image and pre-image here. But this says scale factor of 3. First thing I want to do is connect A to my point of dilation, which is given as P. Let me scoot this over so I can show you. And you're going to take your compass and open it as wide as the distance from point A to our point of dilation, which is point P. So that is this distance here. So this is the original image, so this is a scale factor of 1 or 100%. So the distance from here to here is 1. We want a scale factor of 3. So what we want to do is move our compass up to point A, and keeping the radius of our compass exactly the same, we want to make a point or an arc on that straight line that we drew connecting A to P. And then I want to do the exact same thing and make another arc or an intersection between that straight line with my compass. And this distance here is a scale factor of 2, and here, if I can squeeze it in, is a scale factor of 3. This intersection here would be our A prime. We're going to repeat this process for all of the points on the triangle, and our lines are going to get pretty long because the scale factor of 3 is pretty big. If you think about it, it is 3 times the size of the original image. So now I'm working with B, so I connected B to my point P that I'm dilating about. I am going to take my compass and open so that I have a radius from B to P. It is that distance for that line segment there. And I'm going to move to B, and I'm going to make a line for that intersection, and I'm going to repeat this and go up here. So at that intersection, put my point of my compass, and then put another mark. So again, this here is a scale factor of 1 because that's our original image. It has its original size and shape. So if we extend it out one time, this is a scale factor of 2. This is our scale factor of 3. So this intersection point here is B prime. Let's do this one more time. From C, connecting P to C, drawing a line outward. Measure that distance from P to C, right about there. Move over to C, mark an intersection point on that ray CP. Go over to that intersection point that you just drew, draw another one. And this is our scale factor of 3 here, because this is 1, this is 2, this one is 3. So this here is our C prime. Now we have to connect all of these points, A prime, B prime, C prime, and you can see dilated triangle with a scale factor of 3, so it should be 3 times as large as the original image, and it is. So this here color it in a little bit so you can see it a little bit better. I like to have my students color in their final answer so that there's no confusion which one I'm grading here, in case they make mistakes. That way I know. So the green triangle here is the dilation of a scale factor of 3. Let's go ahead and do a second example, and in this one you will see that we have a scale factor that's less than 1 and it's negative. So less than 1 means that we are going to be smaller than the original image, and the negative sign actually means that we are going to reflect this over point P. So I'm going to label all of my points A, B, C, and this time we are going to take our straight edge, and instead of extending our lines out past the triangle when we are enlarging it, we're going to now extend them backwards past point P. I'm going to color coordinate this because we're going to start getting a lot of lines in here. This red line is my first line that connects A to P, and I'm going to measure the distance from A to P with my compass. And essentially what we're going to do, because we want 1/2, we need to construct a perpendicular bisector. So this is my distance from A to P. I'm going to move around and mark it on the other side of P. So if we take a look at this, this here is our scale factor of a positive 1. This here is the scale factor of negative 1. We want 1/2, negative 1/2, so we need to cut this line. I'll call this point X. We need to cut PX in half. In order to do that, we're going to construct a perpendicular bisector. So if you recall, we need to take our compass and set its radius so that it is just past the halfway point of segment PX. And then we're going to draw arcs on the top and bottom from each point. So I started at endpoint X, I moved now to endpoint P, and this here, connecting these two intersecting points, is the perpendicular bisector of line segment PX. So where these two lines intersect is my A prime. So A prime is here because this distance here is the scale factor of negative 0.5. We're going to repeat this process for all the points B and C. Connect B to P, extend past P. I have to move my ruler down a little bit. I don't think I have enough room there. Measure the distance from P to B, and we're going to duplicate it on the opposite side of P. So we have this distance here, move to P, mark B with a scale factor of negative 1, and then we need to construct our perpendicular bisector here. So shrink down to about the halfway, a little bit more than halfway, construct that perpendicular bisector. We're going to start getting a lot of lines here, so be really careful and mindful of where you are marking everything. This line is my green, so connecting that, that's my perpendicular bisector there. So this intersection point is B prime because this distance here is negative 1/2. And finally, let's do the last vertex, C. So connect C to P, extend past P, or line that up. Find the distance from C to P and mark it on the other side of P. Then we have to find that perpendicular bisector. Distance halfway, a little bit more than halfway. Mark up top. Ooh, this one's, we have to be careful here. This is going to get tricky. Go to the other side. Here I said it's going to get tricky and I don't even remember which line I was working with. Okay, that one. So our intersection point is here and here. So let's connect those. That's our perpendicular bisector for between between this point and point P. So this becomes C prime. Connect all of our points, A prime, B prime, C prime. My purple, my green, and my red points. And we will have our dilation, our constructed dilation, of a negative 1/2. So these ones, when there's a lot going on, you definitely want to color it in so everyone knows what your final answer is and where we are looking. So that there is a scale factor of 1/2, and it's negative because it is, if you look at it, it's like a rotation here, and it's smaller. So that concludes section 4.6, which deals with dilation. So far between the two lessons we looked at how to dilate on a coordinate plane, and then in this lesson you just learned how to construct both an enlargement, a reduction, and with a negative where we flip. Thanks for listening, and I will talk to you again soon. Thanks!